So here we'll verify the mean value theorem for f of x equals 1 over x minus 1 in the closed interval 2 comma 5. First, let's check the two conditions in the hypothesis of the mean value theorem. Let's make sure first that f is continuous in the closed interval 2 comma 5. So when we look at the function f of x, which is equal to 1 over x minus 1, the only problem would happen if the denominator were to be 0. No matter which number we plug in, except for x equals 1, the denominator is never going to be equal to 0, which means the function is defined everywhere with one exception, that is x equals 1. So let's see what happens at f of 1. F of 1, we get 1 over 1 minus 1, which is 1 over 0. So that's undefined. We cannot have a 0 in the denominator. So the only point at which the function is undefined, which means discontinuous, is at x equals 1. So it does have a discontinuity at x equals 1, but x equals 1 lies outside of the interval 2 comma 5. So the function is continuous in the entire interval 2 comma 5. 1 does not lie in the interval 2 comma 5. The only discontinuity is at 1, so therefore the function is continuous everywhere in the given interval. Now we need to check if f is differentiable in the open interval 2 comma 5. So in order to check this, we first need to find the derivative. We need to make sure that the derivative is defined everywhere in the interval 2 comma 5. That's what it means to check for differentiability in the interval 2 comma 5. So what is the derivative of f of x? So f of x is equal to 1 over x minus 1. d by dx of 1 over x is negative 1 over x squared. So d by dx of 1 over x minus 1 is negative 1 over x minus 1 the whole squared. And we are using the chain rule here, d by dx of x minus 1. So this is equal to, so f prime of x is equal to negative 1 over x minus 1 the whole squared. d by dx of x minus 1 is just 1. So now this is the derivative. Now if we think about the function, which is the derivative, the only value of x at which the function f prime of x is undefined is when x equals 1. So when x equals 1, f prime of 1 is equal to negative 1 over 1 minus 1 the whole squared, which is negative 1 over 0, which is undefined. So the derivative isn't undefined at x equals 1, but x equals 1 is not in the interval 2 comma 5, so that's not a problem. So we can conclude that f is differentiable in the entire interval 2 comma 5. So if the two conditions are satisfied, then the mean value theorem guarantees that there is a c in the interval. So there is a value c in the interval 2 comma 5 such that f prime of x is equal to f of b minus f of a divided by b minus a. So in this case, our endpoints a and b are 2 and 5. So this is our a and this is our b. So we know that there is a point x in the interval, at least one, such that f prime of x is equal to f of 5 minus f of 2 divided by 5 minus 2. Now let's plug in the numbers. We know that f of x is equal to 1 over x minus 1. So f of 5 is equal to 1 over 5 minus 1, which is 1 over 4. F of 2 is equal to 1 over 2 minus 1, which is 1 over 1, and that's a 1. So f prime of x is, let's plug in the value or the function f prime of x, which is negative 1 over x minus 1 the whole squared, and that's equal to f of 5 minus f of 2, so that is 1/4 minus 1 divided by 5 minus 2, that is 3. Negative 1 over x minus 1 the whole squared is equal to 1/4 minus 1 is equal to 3/4. Negative 3/4, I'm sorry, it's negative 3/4 divided by 3. So negative 3/4 divided by 3 is equal to negative 3/4 times 1 over 3. So the 3's cancel, and we have 1 over x minus 1 the whole squared, which is equal to negative 1 over 4. So now we can multiply both sides with negative 1 to get rid of the negative sign. So we have 1 over x minus 1 the whole squared is equal to positive 1 over 4. We flip both sides to get x minus 1 the whole squared equals 4. We solve this equation by taking square roots on both sides to get x minus 1 is equal to plus or minus radical 4. We add 1 on both sides to get x equals 1 plus or minus radical 4 is 2. So x is equal to 1 plus 2 comma 1 minus 2. So this is basically x is equal to 3 comma negative 1. So there are 2 points. What we've done here is we have found 2 values of x at which the derivative of the function, basically by solving this equation, we are saying that the derivative of the function at 3 and at negative 1 is equal to f of 5 minus f of 2 divided by 5 minus 2. But we want to find a point within the interval 2 comma 5, within the open interval 2 comma 5, that satisfies the conclusion of the mean value theorem. So negative 1 does not lie in this interval. So therefore x equals 3 is the C, that the value C that satisfies the conclusion of the mean value theorem. So x equals 3 is the one that works for us.